Hi everyone. Today I'm very excited to be presenting on AlphaEvolve, an algorithm created by DeepMind. Basically, what they are doing is that they are using solutions, past solutions, with some evaluation score, and they're using a large language model or an ensemble of large language models to try to create better and better solutions based on what has been seen so far. So this is more or less an LLM guided evolution with handcrafted heuristic scores. So there's an element of human in the loop here, which greatly helps to improve the solutions. So later we'll be discussing, like whether or not the human is necessary or not. I can tell you that it is necessary. I've done some experiments on this, and I'll be sharing my experiments as well for this. So the key question we need to ask ourselves is that can the AI self-improve? Basically, can the AI, given like a problem statement, can it find the solutions that can better and better solve this problem? So this problem ideally should be a problem that has incremental improvements, and it should be objectively evaluated. Like you can see on this diagram here, you have different solutions with different scores. And let's say you start with this initial set, or this was from the previous iteration of solutions. You give this to the prompt of an LLM, and you ask the LLM to generate a new solution that tries to optimize the score. So the new solutions can be quite diverse because sometimes it improves, sometimes it does not. So like let's say it doesn't improve in solution 4 and 6, but occasionally you can get a solution that can improve here. And typically this has been done, when you do genetic algorithms. Yeah, when you do stuff like genetic algorithms, you can sort of try to improve this. But what happens is that, sometimes if you do genetic algorithms, you do random permutations of your solutions. And this kind of random permutation is kind of, it takes quite a while to get to your desired solution. So what could be done is that instead of doing random permutations, you could do some form of guided search. And in this AlphaEvolve paper, the guided search is done by LLMs to sort of guide the solution based on what they have seen before in the past, try to guide to something that might potentially help to improve the fitness score, or in this case, the evaluation function score. So actually quite a lot of parallels to the world we live in right now. There's some natural selection, trying to select for, individuals that have high fitness functions or high scores. And you have some form of evolution that, you base on this. So like maybe this can go in the prompt pool for the next generation. You try to use that as a starting point, and you try to evolve it in small ways to try to see whether you can get something better. So this is pretty cool because if you just use random permutations, it might take forever to get a solution. But if let's say the problem space is with a little bit of insight that LLMs can sort of decipher some pattern and use that pattern to produce better solutions, maybe that would work better. Yeah, and indeed, let's take a look at the kind of results that AlphaEvolve has. So you can see that in AlphaEvolve, they tried it on math problems. Again, math problems is important because math has an objective evaluation function. I mean, we can see whether or not like we are doing packing boxes, you can see what's the amount of space left or how many boxes you can pack. It's a very objective number. So you can use this evaluation function with the ease of knowing that it's always correct. So this is very important because if you do it in a domain where it's a bit subjective, like, if your essay is good, sometimes people might rate it better, sometimes people rate it worse for the same essay. Then you don't know how to improve, you see, because you get varying benchmarks. So very important here that your objective function here is objective. So they use a domain like math. And with the algorithm that they have used in AlphaEvolve, they've managed to improve on 20% of the problems, beating the previous state of the art, which to me is quite impressive. All right. The rest 75% is on par, and the rest of like 5% is worse. But this is really quite impressive because, just by using LLMs based evolution and using a system to store past solutions and trying to get the next best solution again using prompting and using an evaluation function like this, if you keep doing this loop here, they manage to match or do better than world's known solutions. Okay. So of course we need to ask ourselves, is the solution already in the LM. Like the LM already know the solution, and actually they don't. That's why they need to evolve it a few times. So what this could tell us is that, LMs can be good for finding out incremental improvements in the solution code, right? And then you can compose different improvements together for an even greater improvement. So this idea is quite impressive in my opinion, because we're trying to leverage LMs for what they are good at. LMs are good at finding out bugs in the code, or like optimizing certain chunks of code. And if you do this in a step-by-step approach that is enabled by this evolution cycle, you might get better improvements. So I think nothing fancy here. It's just a way of, in a system, prompting the LM to generate better solutions and having a very objective function to gauge whether there's an improvement or not. So in all, that's like what my key takeaway from this paper is. I pause here for a while if you all have anything you want to ask or clarify. All good? All right. So let's move on to the figure that is provided in the AlphaEvolve paper. So I just want to highlight one big thing here. There's a human in the loop here. All right. And this is, in my opinion, very important, because as you will see in the experiments I perform later, if you don't have this human in the loop component to ground, this grounds the LM to know what is the problem, the bounds of the problem, some sample solutions, which you can use this to bootstrap to find better ones. So if you don't have this human in the loop to provide some insights as to what is important, what are the scope to search in, simply doing LM based search can lead to nowhere. All right. So, we always like to say that, like LMs can self-improve, limited extent. Yeah? Because if you don't give some like prompt or some guidance as to how to improve, it might end up getting stuck in a cycle, or it might end up, outputting the same kind of solution code that it doesn't really, advance to the right place. So let me draw you an example illustration. So let's say this is your eval score. So maybe we put a score here. And this is your iterations. So if let's say you don't have any guidance, what will likely happen is that your LM will give a score, something like that. Yeah, because it doesn't really know how to get to the high scores. But if you have some intuitive sense about how to go there, you will actually see like a steady improvement if you give some intuition and guidance to the LM to head towards that direction. I mean, some analogy is like this. If you have a child and you want your child to learn something, like learn how to behave well with people, like you can actively tell the child like, hey, you do not snatch other people's toys, you do not hit other people. Yeah, so that could be in the human defines what, but you define what's good behavior. You characterize some examples of it. And so the LLM, being a great pattern recognizer, is able to use that kind of guidance to map it onto the solutions just by you putting this in the context. So you can see this steady improvement. The paper also shows something like this. You can see this kind of steady improvement happening when you have human-based guidance that is correct. Correct guidance is very important. Later, I'll show you also in the experiments what happens if we do wrong guidance, all right? You do wrong guidance, you probably won't get a good solution, all right? Because, if let's say you tell your child, it's all right to hit people. Yeah, and the score here is like, the highest score is when they are nice to people, right? If let's say you tell them it's nice to hit people, then they will likely never reach there, because they don't think of exploring that area. They think of exploring the opposite area instead. So this human guidance, actually, this is the key difference between like, normal genetic algorithms and, the previous version of this AlphaEvolve is called Fun Search. You can go and check it out. So all these previous algorithms, including Fun Search, they don't really have much of a human in the loop. They try to do everything based on, actually Fun Search had a bit of human in the loop, but AlphaEvolve has more. Yeah, so if you don't give this kind of guidance, it can be very hard for the solution to be found. So, everyone is saying AI can self-improve, AGI is here. Actually, that's nonsense because with just LLMs improving on itself, it will not go anywhere. All right, it will not go anywhere. It will just repeat the same cycle. You need some external guidance in order for the LLM to actually have a breakthrough. Right, and so this human in the loop part is very important. All right, so now that we have defined this human in the loop part, let's see how the whole system works. Okay, first up, we have this thing called prompt sampler. You have a database of records of all your solutions. So for example, you have maybe like solution 1, and then score 1, solution 2, score 2, solution 3, score 3, and then maybe solution n, score n. So one way of doing it is to just pick the top few scores and then use it as the context in your prompt sampler so that you can basically, I'm talking about this process here, using the program database to select some into the program. But if you just select only the top few, maybe you might need some guidance from the worst few solutions also. So there's a way to select this prompt. So you could just do some like maybe top few selections plus representative samples. Yeah, so there are various ways of doing this. I'm not going to go too much in detail for this because it really depends on the problem. So the idea is that you sample some solutions so that you can give a few short kind of prompt to the LM. So this is few short prompting with the scores so that the LM knows, hey, this solution used to get quite a good score. Maybe I should evolve from that solution. Right. So this is the prompt sampler. Next, we give in more of the meta information from the human. So like the human might say, hey, in this problem of graphs, try to find minimum distance, the kind of stuff that's a bit more intuitive. The human could define that, and that can go into context as well, so as to help to prune the search space even more. So the self-improvement happens in a very narrow search space, which can be more conducive to find the right solutions. Next up, we have this LLMs ensemble. So this one is basically, using various LLMs to get different solutions. So actually, you can also use one LLM, but the solution you get might be less stochastic, more of a certain kind, which means that you don't explore much of the search space. You can use various LLMs prompted with different kinds of exploration techniques to get you different codes here. In the paper, what they did was they used a Gemini Pro 2.5 and a Gemini Pro. So this helps to, at the expense of some time, 2.5 might take a while, you get better solutions. But this Gemini Pro Flash, you get normal, but you iterate faster. So you can explore more of the search space. So they do this kind of two-prong technique, one a bit more refined, a bit slower to generate, but can potentially get better solutions, and the other just to, try out more diverse solutions. So how you implement this, actually a lot of nuances also. In fact, this LLM's ensemble, um, they also have different contexts over here. They do stochastic sampling of various known solutions. So in some sense, sometimes if they sample solution A, the output is generated a variance of solution A. Sometimes they sample solution B, then the output is variance of solution B. You also help to expand the search space. So the idea here is to expand promising search spaces. You either do it by, in the paper they mentioned they use some probability to, see what chunk of code to provide in the context. That's one part here. You can also use your LLMs prompted differently or just use different LLMs to get different outputs. Okay, so this is about expanding search space. Next up we have the evaluation. So this evaluation is very important also. Okay, you need an objective evaluation so you can be sure whether your solution is improving. Okay, so you run through all the output of your LLMs through this evaluator. Maybe select the best few ones, and then you put them in the database. Or you can put everything in the database, and then the selection can come from here, this part. Okay, so that's more or less AlphaEvolve in a loop. The key idea is given some human guidance, the LLM is able to consider the previous few solutions and their scores and come up with new solutions. And then we evaluate those new solutions, put them in the pool, and repeat this cycle again and again until we decide that, that's enough. All right. So theoretically, if the LMs are able to generate any kind of solution, theoretically, you might stumble on the right solution. Okay? But that's theoretically, because LMs itself might have some bias. It might be biased towards generating certain things and might miss the solution altogether if it's quite different from what the LM has seen in its training data. And that's why the human guidance is important. It can help to steer towards there. But I would say that there are certain kinds of problems, even with human guidance, we may not solve. Those kind of problems are problems where the human doesn't even know how to find the solution. Right. So um, of course, this AlphaEvolve works for like math that people already know some intuitive idea about what kind of solution we expect to find. But if we do in the domain, like maybe like you want to optimize hyperparameters of a neural network, no, maybe this can't work. Yeah. So there's a huge element of the human in the loop here that helps the AlphaEvolve work quite well. Okay, I pause here if you all have anything you want to ask or clarify. Okay.
Nothing at the moment. Let me listen to the explanation. Very helpful. Thank you.
Okay. Great. Hopefully you'll understand this part. So let me go to the next slide. So this is the code version of how this works. So of course, the first part is you want to do a prompting to generate the solutions. I mean, in the code, they basically sample the database first. Okay, then based on that, they build the prompt, use the different LLMs to generate solutions. Over here, they call it diff because they apply the differences in the code to update to get a new code. All right. You can also change the whole code. I mean, over here, they apply difference because their code base can be quite big, like a few files and stuff. So we apply the difference to the parent program to get a new program. We evaluate this new program, and then we add this into the database. And then we repeat again and again and again until we get something that is quite nice, then we stop. Or after a few iterations of this, we stop. So I'm not going to go through too much here because I've explained that in the previous slide. And now we are going to do something quite interesting. So over the last week, I've tried to do my own version of AlphaEvolve in a code. So I have this system called PassYAML that does structured output. So basically, I try to do my own version of AlphaEvolve that does a very interesting problem. And the problem is whether it can find out my name. So the correct answer is John. If they find JOHN, you get full points for it. Okay. So I basically asked it to, generate a Python function named my solution. Okay. Ask them to output some analysis, thoughts, and next code. So I realized that if you don't do this analysis and thoughts, this is actually called chain of thought prompting. I realized if you don't do this chain of thought prompting, the solution is quite low quality. So at least asking them to think about what has happened before helps to get better code. All right. Ask them to maximize the eval function score, seek out promising variations. Okay, ask them to do not exploit, just explore. Because sometimes LMs will just say, hey, this score is very good. Let's repeat the solution again. And that's not what we want. We want to get new solutions. We don't want to get the same solutions. So, you have to prompt it quite actively. All right. Variations should be small and avoid radical changes. Because I find that if your changes are too big, sometimes you want to explore the optima. So let's say this is your solution space, and this is your score or your eval function score, and on the x-axis here you have your parameters. So if you want to do some exploration of this search space, we normally don't want to, like, let's say you're over here, you want to slowly inch your way up here. You don't want to explore too much, like go all the way here like that. Yeah, you don't want to do that. So I actually did that in the prompt. So it's quite cool because like usually if you do those kind of swarm algorithms, genetic algorithms, you normally program this in a way like say, oh, you do a random sampling within a local radius. Yeah. So in LMs, you just say, do the variations to be small. Yeah. So I also realized if I don't put this thing in the prompt, it doesn't really work. Okay, they tend to explore too much. So the prompting actually is very, very important for this. And just a new way of search. It's a LLM guided search. Right? It took me a while to find out this prompt. I spent about 1 week trying to create this to try to see whether it can work. This kind of prompt works well. So I had to emphasize again, do not repeat the past solutions because, as usual, LLMs tend to exploit quite a lot. So all these prompts here are just to tell it to create new solutions and not the old ones. Uh, Ask it to avoid the randomness because sometimes the solution, it gives me a random letter selection. And if you give a random letter selection, the code wouldn't know what has been tried before, right? So specifically for this problem, when given like a 4-letter word, they are supposed to output the word. We don't want it to output a random word. Okay, we want it to output the actual word itself. All right, use the problem hint to guide the solution. So over here in the code, because everything is code, I do in a safe execution environment. I give it only certain imports. So in this case, the imports are string and random, which helps them to, do some string manipulation. This is the current program to evolve from. So I have some loop to find out what's the best score, and then this will be the program they are designated to exploit from. All right, the top 20 past solutions and their scores. The input-output format, which details like what is expected in this function and what is expected to output in this function. The problem hint, which is some guidance, the human guidance as to how to evolve the function. And I also provide an eval function description that tells it like how the evaluation is working so that it knows how to cater the solution to best do well in the eval function. So I realize if you don't provide this, it's like blindly finding solutions is bad. So I kind of realized that you need to provide an eval function description. So all this not really shown in the paper. I feel like the AlphaEvolve paper missed out quite a lot of details on how they did this. I had to kind of learn this on my own. So, if you don't do all this kind of stuff, the AlphaEvolve loop may not work because you want the LM to evolve in a meaningful way. You need to tell it what are the parameters to evolve, how to evolve. You need to tell it like how you are evaluating it. Because the same analogy is like this. If you are teaching your child not to hit people, or not to snatch away the toys. If you're telling your child to do that, you kind of want to tell upfront, this is my evaluation function, rather than just let it to blind guess as to how they are evaluated. So yeah, I hope you see the analogy here. Something like, if you want to do well in an exam, you need to tell people how you are going to score them, right? Not just give them like MCQ and then don't give them the like if you don't tell them, hey, the evaluation is about number of correct answers. Sometimes they might think, oh, the evaluation is about number of wrong answers. Yeah, so you kind of need to tell what kind of evaluation that you are using. And this together with like the problem statement in the like problem hint is quite important to help to evolve the solution in the right way. So over here, I showed like how the analysis thoughts and codes work. And then, yep, let's take a look at how the program works. Okay, so this is not the actual AlphaEvolve. I couldn't find the code, but what I can say is that this is a simplified version of how the whole loop works. It still works. So I'm excited to show you this. It took me 1 week of effort to code this out. Let me show you how this works. Okay, can you see this Jupyter notebook? Can give me a thumbs up if you can see it. Okay, so I'm going to show you the code of AlphaEvolve that I've created. And this code, just to give you a brief overview of this, the answer is John, and they are sort of guess a 4-letter word. And we either evaluate ordinal differences between the guess word, which means that if let's say they give me JOLN, okay, compared to JOHN, the evaluation score will give them -1, okay, because there's 1 letter difference. Okay, if let's say they have like JO, what's before L? K. If let's say JOKN, right? Then the evaluation score will give them -2. Okay, so that's the ordinal difference score. And the absolute score basically is like the number of correct letters. So if you get JOKN, the absolute score will give you 3 because there's 3 letters correct. So I just want to see, based on different evaluation functions, one is absolute evaluation function, and the other one is relative evaluation function, how good will the evolution be, all right? And, to my surprise, Your guess which one would be better? I mean, if you look at here, you know, you guess which one is better for evolution. Relative score, which tells you the relative difference in terms of the number of letters in between, or an absolute number of correct letters. You guess which one is better for evolution? Anyone?
I think the ordering, I think there was a game that we used to play, right? I remember,
The
I,
Wordle, is it?
I can't remember. It was a long time ago. It's like you hide behind, and I think number to get it right, right? The order is actually more important. Of course, you number of correct plus order. This how I think, right? Basically, yeah. Because
Mhm.
ultimately, a word is not just the right character; it's the ordering, basically. Yeah. Also, yeah, this is my
So you
guess,
think
huh?
the relative will be better, right?
Yeah, relative ordering, you mean?
This relative means like if you look at the number of for each letter, you see how many letters difference it is to the ground truth.
Of
And
course, of
yeah,
course.
great. So that was my initial thought also. But
Mm-hmm.
I realized after I did the experiment, actually
Mm.
LMs for this problem, they actually use apps is better. Okay, and I realized why.
What is apps means that?
That means number of correct letters.
Oh, I see.
Yeah,
Yeah, I'm not surprising because machine thinking is different from human thinking, right? Yeah.
correct, correct. So it turns out that the LMs can't really count very well. So that's why the relative is not that good.
Yeah, yeah, yeah. I think human thinking is different from machine because they can do certain raw power that human are not that good at, right? Basically. Yeah.
Correct. So this is also my gripe with AlphaEvolve. If we use evaluation scores that are more of a continuous scale, you would think that LLMs can count, but actually they can't. They appear to count because of the training data, but they actually can't really count very well. All right.
Yeah,
So,
yeah.
yep. So, yep, these are some of the quirks of LLMs we have to live with. But overall, LLM is quite a good evolution driver. It just cannot drive those kind of optimization problems with like a lot of parameters that well. Like for that, you might need to use Bayesian optimization or something. If let's say the parameters don't have any intuitive sense about how to evolve it. All right. So this is how I did the experiment. So I did with three hints, three human guidance. One is I give them the answer directly. So no surprise in this, they got the answer in the first try. Medium, I give them like, oh, your output a four-letter English word starting with J. So for the absolute score, they solve it in 12 tries. Not bad, actually. Not bad. And the medium, they solve it in 29 tries. For hard, I give them like output only a four-letter word. I don't even tell them it's a name or anything. Um, because if I tell them four-letter name, I realize that they get it in one try because the first name they try is John. They say John is the most common name, so they try John. So not fun, right? So we have to like give it a word without any hints at all, and um, it didn't really solve the hard well. I mean, if I extend it to 100 iterations, sometimes it solves, sometimes it doesn't. So there's a bit of a limitation here. I realized that you need to actually constrain your problem space quite a bit. If not, your alpha evolve may not be able to reach the right space, although it does give improvements. So, if you run this cycle enough times with enough human guidance at different directions, maybe you can solve it. So I'm quite impressed with the way LMs can self-evolve. So yeah, I mean, this is just an experiment. Of course, you need some guidance here and there, but overall, the concept is legit. All right, it's legit. I've tried it out. Um, I realized that the key issue is, lack of stochasticity sometimes because, with LMs, sometimes even if you set the temperature to be higher, sometimes it only knows how to output certain solutions in certain configurations. And, if you sample the same solution again, that is bad, that bad solution may not appear in your sampled context. Then it keeps trying again. So this is what I realized happened. And this means that you kind of need to have a way to increase stochasticity, maybe have more varied outputs from different LMs and so on, so that you can still progress and not get stuck at one solution. So maybe that's why they use an LM ensemble so that they don't get stuck. All right. Another interesting experiment I did was I used adversarial hints. Okay, I give human guidance that is wrong. All right, and see whether you can affect the evolution. So if I ask it to output stuff like output Mary, it doesn't get the answer at all because it's too constrained by the guidance. Right? But if I output a girl's name, Eventually it starts with Jane and go to Joan, and eventually sort of say like, John is a guy's name, but sometimes can be used for girls. So it gets the right answer. If the hint is wrong, but the hint is generally correct, you can still get the right answer. So this is something that I want to highlight. The guidance is very important. Um, Incorrect guidance can lead to exploring the wrong search space. And the LMs will likely not recover from this. Yeah. So this is very, very important. I have tried this, and this is why the AlphaEvolve paper, as much as it is a breakthrough, it comes with a lot of human guidance, in my opinion, because if not, how can you beat the Strassens algorithm just by LM search? No, it really requires some kind of insights. Yep. Derek, you want to say something?
Um, I have this concern in the back of my mind. So for the paper, they used Gemini 2.5, and then they used the Gemini latest Flash version of the 2.5, I think. Um, and I was trying to look it up. They're very vague about the LLM, about its internal reasoning. I don't know if it does like internal chain of thought reasoning or not. But my concern is with this architecture, the issue with why guidance is so important. I think it ties back to the issue with the LLM and its inability to have adaptive, like basically an adaptive learning. Like with the machine learning, we had the Atom optimizer with the adaptive learning rate, and that allowed the neural networks to become truly intelligent and practical, as opposed to like the stochastic gradient, which made them very slow with their sampling. So my concern is that we're applying that I guess framework to this higher level of abstraction of basically code reasoning and mathematical reasoning. But my issue is that these LLMs don't seem to be able to work with relative scoring. They're only able to use absolute scoring, and that's causing me concern. Is that because they might not be able to understand relative scoring at a reasoning level or at a innate level. They're not able to understand the concept of like depths and gradients and like scales of wrongness. Basically, if I give you a really, really wrong guess, you give like -50 or something crazy, I'm able to immediately know, oh, I'm way off the mark. My line of reasoning is inherently wrong. I need to do the opposite of my chain of reasoning in order to get closer and make a huge jump closer to the goal. With these LLMs, I fear that the ensemble is a good touch to help with the robustness of the stochastics and the sampling, but my concern is that it's using a brute force approach to an inherent issue with these LLMs, and that's with their, I guess, inability with their internal reasoning to gauge and utilize relative scoring and relative guidance to their maximum potential. Like we can do that with machine learning. We can use the Atom optimizer for that. But if we try to apply that framework with LLMs, these LLMs and their training, my issue is that they're not going to be able to utilize that to the next level and go to that next level of like sampling efficiency and then sampling optimization. It doesn't really connect so much with like trying to optimize their final solutions. I think that's going to be inherently limited to your data quality and to your representation quality, like the abstractions the neural network's capable of. I think that's a separate issue. I think the issue I'm connecting with, and may or may not be connected to the that other issue of final output, is going to be the sampling issue. Because I don't think these LLMs are able to pick up on stuff. They're not able to like use that relative reasoning. They're just using absolute reasoning, and it's very sluggish, and it's affecting the outputs they're capable of, their samples, and the potential final solutions that they can reach. I think is my point.
Mm.
But I like both of your inputs.
Yeah, I do think there's some limitations with regards to what the LM can understand. So actually, the LMs can also work in this way. LMs generate a pipeline to evaluate. And then you can use your Adam optimizer, or you can use your other optimization frameworks to evolve. So you can use LMs as a meta evolve loop. Also, you may not use it to directly evolve the score. So this is also what's possible. Like basically you do a meta loop of evolution where the LMs do the framework for I mean, I actually wanted to do some experiments. I didn't have time for this, but I do think if I use a meta loop to kind of ask the LM to define a structure to test out various solutions, this might solve my John problem quite easily. So, it depends on what level you use your LM at. LMs are actually a bit more high level. It doesn't interpret numbers that well. So maybe it's best to use a specialized program to interpret those numbers. So those are some insights that I've gained from doing the experiments. And now let's move to
Sorry,
show
can
you.
I chime in here?
Oh, yes.
So, I don't, okay, I have a different take on this issue.
Okay.
First of all, you said not good at numbers. Well, I think the fact that they can discover this better algorithm to do multiple matrix multiplication, with the help of the entire system. I mean, not it's granted it's not vanilla LLM, right? But the fact that it can do that, and according to what I know so far, there's no other, like any other way, any other method, no other method has produced um any or whatever, like search or whatever. We have not used other method to discover any matrix multiplication algorithm better, right? So I mean, doesn't that already speak for itself?
Yeah, so LMs
Yeah.
are great at finding patterns. So but they need to have some guidance and need to have some form of.
I already said that. I granted it's a whole system, right? But it's a very important component in it. And my point is, I'm not sure if researchers have been trying to find a better matrix multiplication algorithm. But the fact that it's the first one that beats the one that has been using for the past, I don't know how many years, decades. And that's just crazy, right?
Yes, that's why I'm quite optimistic with AlphaEvolve like architectures. I'm going to do some work on
Yeah,
it.
so my point is we shouldn't just lightly dismiss it by saying, oh, it's not good at numbers. But the fact that it knows it's not good at numbers and it knows to use code to bypass this inherent weakness, I mean, it's just crazy to me.
Now, I mean, over here, I'm saying that the score is actually used for the prompting. So the LM needs to know which numbers are better. So in this case, if let's say we tell it the evaluation function does this kind of description, does this kind of how is it evaluated, the LM is able to use the English semantics of the function to sort of guide itself. So I'm saying that if you just give it the raw numbers, it's not that great. But you need to augment it with
I'm not
different.
disagreeing on
Yeah.
that point in particular.
Mhm.
But I don't know if you guys know, like I think it's from 2 or 3 years ago, there's a result I think it's also on the exact same problem, matrix multiplication. But that time I think they discover, I think it's on Nature, if I'm not wrong. The result is published on Nature. It's through pure RL method.
Alpha tensor, right? The
Yes,
one that
yes, yes. You
discover
know it,
the
man. You know it.
Stressen's algorithm.
Yeah. Um, so I find it very mind-blowing because that in that case, right, they dedicate they use the whole entire method is specifically designed for this problem, right? It's like on a whole optimization, whatever, it's all designed to solve this problem, matrix multiplication. And I think the result they discover is not, I think technically speaking, it's not strictly always better, right? It's not, if I remember correctly, I don't remember the actual details, but I think it's not strictly better. It's like stochastically better or something. Or it's doing some optimization, not on the mathematics level, but on the, oh yeah, I think it's on the code, on the code execution level, like very low level, if I remember correctly. So it's so in a sense it's, yeah, yes, it's an improvement, but it's not like what I feel is not as impressive as this one. But what's more impressive is this system is not specifically designed for this purpose. You can use it for other kind of um, scientific discovery as well. And yeah, and LM is also not specifically designed to solve this type of problem. And as you said, inherently it is it is supposed to be bad at numbers and mathematics. So all these things put together, yeah, that's what makes me feel it's so impressive. Yeah.
Oh, definitely. I absolutely agree that it's impressive. That's why I wanted to do a video on this after 2 months of not doing YouTube. So yeah, this is a paper that actually like sparked some insights in me that, if we could use LMs with their apparent weaknesses and complement it with some framework, that is actually quite promising. So definitely agree with that. But before we discuss further, let me just run through this code so that at least I cover something here. We can discuss something later. All right, so I will just show you how this is done. So first install Agent Joe. I mean, you can use anything that has structured output. You don't have to use Agent Joe. You can use instructor and so on. So define the LM. Here I realize GPT 4.1 is better than 4.0 mini. 4 mini doesn't really understand letters that well, but 4.1 does. So great job to OpenAI for that. Right. I also tried using reasoning models like O3 mini, O4 mini. In general, the reasoning models overthink and the performance is worse for some reason. So just food for thought. Yeah, but 4.1 works quite well for this. So over here, we set up some evaluation function where the first one is to see whether or not like the absolute distance between the inputs and ground truth for each letter. So I thought this will work better. Surprisingly, it doesn't. So next up, we have the number of correct letters. So like A, B, C, and ADC will give you 2 because A and C are correct. So you can see this is how it works. Like eval exact will give you 1 between ABC and ACB because A is the same. Eval relative between ABC and ACB will give you -2 because there's 1 letter difference in B to C and C to B. So this is how the eval works. And I do a safe execution loop using safe built-ins and so on. Exact details, you can look at the code. I put the link in the slides. So execute the code, run the code, and give the output of the code. So the output is either the answer or is an error message, which the LM can use to error correct in the next cycle as well. So I output some hints. So like the hints I mentioned earlier, the easy one is the answer itself. I provide your output John. Medium, I ask it to output a word starting with J. Hard, I ask it to output a four-letter word without even giving any hints at all. So the input-output format quite important. You need to tell the LMs what kind of inputs to take in for this code and what kind of outputs to output. Okay, this is important because we are evolving the code itself. Well, we are not evolving language. Okay, we are evolving code. So it needs to know what kind of code to output. I think this is quite a great decision for them to use code because LMs do code really, really, really well. If you use the LM statistics as an example from Claude, from OpenAI, even I don't know whether Google released, but most of the LM use cases are actually for coding. So LMs are awesome. They are great at coding. So I think this is a great direction to evolve the code. All right. So that's why we need to give it the input and output for this code. So we do a loop. So we have a ground truth, John. I only allow it string. Sorry, I didn't allow it random. I took out random. So I run the experiment. Basically for this experiment, I take the 20 best solutions. Okay, I give it the prompt which I explained just now. All right, and I ask it to output the chain of thought prompting, analysis, thoughts, and code. I realize if I take away any component for this, the code is not that great. So this chain of thought is important. All right. So execute the code, interpret the code result, record the code result in the database of solutions, update the best code solution because we will evolve from the best code solution. Now, of course, you can augment this algorithm to evolve from the top 3 solutions and you have 3 different evolution chambers. But over here, I just do 1. All right. And then after that, if let's say we solve it, we exit. All right. So I've done 2 different versions of experiments. One is the expressive loss function, which tells you the number of letters difference, total number of letters difference for each letter. And if you just do like easy, you can see this is the hint given. Analysis, the problem since hint says output John, let's output John, and then the solution is output John. And great, they solved it. All right, so that's expected. I mean, I gave them the answer. So next, I asked it output letter starting with J. So it tries one of the common words, just, joke. It tries jump, and you realize that, hey, maybe I should try something else. So try just, and then you realize that, hey, jump and just were -13 and -23. So jump is better. I should modify something related to jump. So it got junk and so on. And then after a while, you can see, I'm just going to skip a bit of this. You can read this on the GitHub to run. Okay, eventually it will hit something like, hey, oh, June, not bad. So let's try to do something related. So I try to do join. No, very good. Then from join, you realize one letter difference. So it probably thinks that, hey, trying John is better. So you can see that there's a logical evolution of the solution, and it basically based on the evaluation function to try to give you better and better code. And I think this is very promising because it means that if your domain is subject to semantic analysis, this LM guided evolution can make it. You see, it took 29 iterations, but it got the answer. And it's quite impressive actually, if you ask me. Like this is like real learning happening here, right? But just a word of caution. I tried to ask the LM at each cycle to generate some learning insights to prompt the next cycle. After I asked it to generate the learning insights, it did not work for this anymore. So this is something important. I didn't put the learning insights here. So if you ask the LM to generate learning insights for each evolution, it may make the program worse, okay? Because when you ask the LM to give some insights as to why it didn't work or why it worked, sometimes the insight is wrong. So if you give the insight and you prompt it in the prompt to generate the solution, you might get stuck in its own local cycle of thinking.
Sorry,
So
here can I again chime in a little bit?
oh yeah, go ahead. Yeah.
It's interesting because I think this is like a counterpoint to one of your opinion I heard last time, which is the intermediate reasoning, whether it's correct or wrong, it doesn't matter so long as the final result is correct. But here it seems to be against that opinion, right? Because it seems if your intermediate reasoning or insights is wrong, then in this case it makes it less less efficient, right?
That last time I say that is because the reasoning process, if let's say you use a wrong reasoning process but you still get the right answer, then that's great. But over here, if I in the context give it the wrong learning insights, you might never get the right solution. So
So
it's
in a way,
yeah.
like it is still like in a way a small probably invent to use the wrong reasoning to get the correct answer.
Yeah, no, that one was because we already have the ground truth, you see. So we could, do some analysis of what went wrong. But here we don't have the ground truth, so it's a bit harder to do that.
Okay, I see. Another question I have here is, what's a backbone model you used?
4.1 mini. Sorry, GPT 4.1.
4.1. Also, it's a very recent experiment.
Yeah, I just did it last week.
Okay. Last
Yeah.
question. So it seems like I might not get the entire picture, but it seems the way you prompt it to do the evolution is not exactly the same as from what I understand, the same as in the traditional sense evolutionary algorithm does, right?
Yeah, because AlphaEvolve also didn't use like random generations and stuff. They also use LM guided evolution. So I'm trying to mimic that.
But they still have the steps of generating and selecting better prompts, right?
Yeah, that's what I'm doing also. Generate and select better solutions. Of course, they also have a meta loop where they generate meta prompts to
Yeah,
it.
so
Yeah.
are you saying they are not maybe because I have not read the paper in detail, so you are saying they are actually not using the genetic algorithm to generate,
Yeah, no. They are using LM based evolution where the LM generates the solution.
because I have read other papers actually use the strictly following the definition of the genetic algorithm. They actually do things like select, then do the the mutation, and
So I think AlphaEvolve can be superior to genetic algorithms, traditional ones,
I see.
because random evolution can take forever to reach the solution. While the LM guided evolution with the right guidance is a more targeted search.
Okay, I see.
Yeah, but then again, it might get stuck in local optima and so on. And that's why you need multiple agents or multiple LLMs to sample different parts of the search space. You also need different kind of prompting techniques to prompt it to different parts of the search space. And you might even have one agent that just does random mutations because it's always good to have diverse search spaces. So there's no one best solution for every problem. Each problem has different solutions. If the problem was find a random string of digits and there's no meaning to it, then maybe genetic algorithm will do better than LM guided search.
Okay.
Yep. Okay, so yeah, so this is for medium. For hard, it gets pretty close, but it's not really able to discern that maybe the starting letter should be J. It got stuck in LO, and then if you look at the everything over here, because of the past kind of examples that he has tried, it got stuck thinking that the word likely starts with LO and ends with N, and so it kind of sort of cuts off the search space from the search. So this is why I say the guidance is important, because with LLMs you might find the pattern, but the pattern might be wrong. so so if you guide it correctly, you might constrain what kind of patterns it can find. Like in the earlier case, I say start with J, right? So it constrains and starts with J, and it's able to think of words better with starts with J. But once it free forms does it, sometimes it may not get the answer. Yeah. So I think if you give it enough time, maybe it might evolve. But my experience with LLMs is that once it's stuck, it's stuck. Yeah. So maybe for this kind of case, we might need some random permutation. Somehow get the J out. Then that might work. Okay. So I've actually got some success with this before. It really depends on luck. Yeah, whether the token generated start with J, because sometimes they try the word joke, and then from joke they 3 or 4 tries they get John. Okay, but in this case I tried it recently, it didn't work. Okay, so there's some food for thought here about using LLM based evolution is that LLMs can get stuck based on the prompt that you give them. All right, so that's why I say a hybrid approach is good. In the paper for AlphaEvolve, they use a stochastic sampling of certain good solutions so that you start from different good solutions and you try to evolve from there. So that might be a way to counter this kind of I call it mode collapse. You collapse into the wrong thinking. Yeah, I tried to give it learning insights and so on. I tried quite a couple of amendments to this base function, and to my surprise, asking it to learn may not be the best approach. So, I always hear people say LMs can self-improve, it can self-learn the stuff. In fact, I tried it for my Pokemon game also. Recently tried Agent Joe plays Pokemon. I need to really, hammer down on the kind of insights you should generate. Like, oh, you should record conversations, or you should record items collected. If you don't give it any of this at all, it may not record it. It may not think it's important. So there's a limit to what LLMs can understand. And if you have a structured framework to try to guide it to extract information, it does really well. If that framework is correct. Like if you want to plan goals, you can use the SMART framework, that kind of you have to do business stuff, you can use the SWOT analysis. Did I get it right? SWOT, right? Yeah. So if you have that kind of framework, you prompt the LM to generate stuff like that, it can work quite well. But if you ask it to freeform generate, hey, what should you learn from it? Good luck. Yeah, good luck. Yeah, I tried. It doesn't really work that well, right? Especially if it's not in the training set. Okay, so next up, harder eval function. Ask it to output John with an absolute score. It works. Medium. So you see jump, and then after that, it managed to get to John pretty fast. Iteration 12. It's quite fast actually, like because now that it knows that it's an absolute score, it knows that hey, there's 3 letters that are correct. So this basically narrows the search space even more than the relative score where they don't even know whether the letter is correct. So that might be explain why absolute score is more superior here. In fact, if you combine both absolute and relative scores, I think it might work better. But it might work worse also. I haven't tried it out. Because LMs, if you give it too much context, sometimes it goes haywire. So it's a subtle art of deciding what the LM can handle and what it cannot. And for those that it cannot, you try to offload it to programs, offload it to rule-based algorithms. So there's a lot of things to explore here. I think AlphaEvolve just touched the surface of what can be done with LM guided evolution. There's a lot more that we need to think about. And later we can discuss. I have a whole list of discussion questions for us later. So for hard, for hard, I tried 50 times. Sorry, where was it? 50 times. Yeah, I don't really have the answers here. Oh, did it work for that? Oh no, Sorry, this is not the hard one is here. So after 50 times, it didn't really work. Sometimes it works, sometimes it doesn't. So it's a bit stochastic. If you try it enough times, maybe it will work. So yeah, set the temperature higher, try it, it might work. So sometimes maybe the solution is found just because you try enough times. Like there's this guy who did Arc AGI challenge. He used GPT-4 and he tried it like many, many iterations, and he realized the more iterations he tried, the higher the chance of finding a solution. Yeah, I think that was can't remember his name, but he did do quite well for the training and the eval set. So yeah, you can randomly sample a solution, provided that some form of the solution is already there in the training set, right? But over here, I purposely use this word thing because they probably don't have this in the training set. Yeah, so I try to do something different, and it's also easier for us to visualize, right? I mean, if I use numbers, it's very hard to see, but if I use words, it's easier to understand. Okay, so this is yeah, sorry, anyone want to say something?
Nope.
Okay, yeah. Let's move on to what if you give the wrong hint. So over here, I'll put a girl's name as the hint, which is wrong because John is a guy's name, right? And you can see that after a while, it evolves from like Joan or this, and then it realized that, hey, Joanne is not bad, and June, and then after that, John. All right. So it also knows that, this may not be a girl's name, but, they just try to change it. Yeah. Okay. Over here, it did not say that it's not a girl's name, but sometimes when I try it, it does say. Yeah. But based on this, if your hint is slightly wrong, but it's still plausible, this might still work. But if you output like stuff like this, output Mary, then good luck. You see all the solutions here, Mary, 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 Mary. It doesn't really evolve beyond that. So that's why I say guidance is very important. I've tried it out, and basically I did this because I wanted to see how far LM prompting can get us. And I realized that it can get us somewhere, but you really need the human in the loop part to constrain the evolution. If not, you might get stuck in different cycles. So all this, I have the link in the slide. Let me go back to the slides first so that we have some time for discussion. Okay, yeah. Maybe I just pause for 1-2 minutes. You all have anything you want to ask about the demo or anything in general before I move on?
So John, what else will you cover after this part, basically?
Oh, I'm just going in the details of the algorithm for AlphaEvolve and the discussion.
Oh, get into the evolve.
Yeah.
Maybe before you get into the detail, because I think that is specific. First of all, very grateful you're organizing this session.
Oh, yeah.
Next time, given you spend the time, might be good to get more people involved, all right? To get more, I thought more people will probably be more interested in this because this is such an important topic.
Oh, no worries. They will always discuss after the YouTube is out.
Oh, really?
Yeah,
I
yeah,
see.
yeah.
I see. Okay, I see. Okay. So if I understand the way I understand without going to the nitty-gritty detail, to me, this is just first of all, is this a novel idea at all? Evolutionary system? Number one. Okay, this I actually have questions, right? From the way you have shared with me just now, I don't find anything that novel, basically by DeepMind, frankly speaking. Because they are just, in my opinion, they are solving the constraint problem using LLM instead of deterministic code, right? Basically, because LLM has some randomness to it, basically. Is my understanding correct, basically?
It's just a different way of evolution. I mean, in the past, we
Yeah.
don't really use code to evolve, you see. So this is I think it's novel in the sense that we're using ensembles of LLMs and guided evolution. It's
Yeah.
not something totally new, but it's something that is interesting enough to
Yeah,
get
it's something
results.
new in a sense that because now we have the LLM as an engine available and multiple of them, therefore you can use it to generate scenario for constraint solving, right? Then you add in the human intuition as part of the guidance to guide it better, right? Basically. Just that you can write a piece of code to evolve through genetic and many other mechanisms.
Yeah, yeah.
Is my understanding correctly? So that is the gist part is that he's using LLM. He's also using a mixture of LLM as part of the tools to build it, right? Basically. Is that
Yeah,
my
yeah.
understanding?
That's correct.
I
So
see.
it's a framework in which we use the LMs to evolve, and how we choose the prompt and so on. All these are part of the framework. So I think it's the framework that is interesting, not the LLM guided code, but because that one we already know. But it's how we
Uh-huh.
do them in the framework, and they got very impressive results. So that's the first. I think the impressive results is maybe largely due to human guidance. We don't know, but it's still impressive because humans haven't been able to find solutions that beat the state of the art. So you see over here, it beat human state of the art on 20% of the constructions, which means that even if you use human intuition, the human intuition cannot get you there. So
Yeah,
yeah,
I think I do agree. You definitely enhance. So you have one more channel of innovation, right? It's proposed by the LLM engine, right? Is that correct?
yeah. So the way that we improve on existing good solutions based on past knowledge the LM might already have,
Mm-hmm.
I think that is very insightful because it shows that a human AI collaboration can actually achieve better than what humans can do and what AIs can do. I think,
No, yeah,
yeah,
there's no question about that. That one I have no question. Definitely, right? Because just like one person thinking, you have two-person collaborating, right? Then a three-person working with one LLM or one three-person working with 10 LLM, you definitely will improve. The question is the coordination and the collaboration framework, right? That's my intuition now telling me, right? Basically. Is my
that's right.
understanding correct? Okay. Okay, good. Thank you. Yeah.
Yeah, no worries. Yeah, so I think this is quite an interesting thing. Although, the idea of using LM to generate code is not new. This whole framework like this is interesting. And, this is just the beginning. Like, of course, LMs itself are not going to be the only thing in this mechanism. There's going to be rule-based things as well that you can add in. And let's just take a look at how, so all these demo results I have described just now, so I'll skip. The link is down here. I'll share the slides with the link. You can go and see the notebook in detail, run it yourself, try for new problems and so on. So this is the motivation for the paper. So the paper is like this. You want to represent the candidates as algorithms, use LMs to generate, critique, evolve. And the idea is you generate using code execution and automatic evaluation. So you use an objective, use an objective evaluation because it's very, very important for improving the solutions. So I mean, previously I covered on GRPO, Group Relative Policy Optimization. They also do on objective solutions because if you don't do objective solutions, you might get the wrong kind of guidance. So over here, you can see guidance is important. If we can use automated guidance, this one is via evaluation functions, it is better. And in fact, the fun search work, they try to generate their own evaluation functions and evolve the evaluation functions as well, which I think is interesting. So there's various ways you can apply this evolution. Apply it to the code, sections of code, apply it to, if you are doing meta generation of that code, you can apply it to the meta generation. You can also apply it to the evaluation function. You can also apply AlphaEvolve to the search function, all right, to search for past solutions. Remember, I talked about how you can select representative samples to prompt the LM. You can evolve that search process as well. In fact, you can evolve both of them jointly. The possibilities are quite endless. Anything that can actually be changed, you can evolve it, all right? And, if you evolve it at a high level, enough level, with enough compute, I'm sure the whole system would be very dynamic and very versatile. So we are waiting for compute to scale up. And actually, this system, if you incorporate with more structured uh, generation, it might actually work very, very well because you use LMs to guide. You also use some sort of random permutation to explore a bit. You augment what LMs are weak at with structured algorithms. This is very powerful. I think they also did something like this in AlphaEvolve. Very, very effective. Um, so the key thing here is, again, you can see, avoid any incorrect suggestions. So I must emphasize this again. Any guidance, regardless whether it comes from the human or it comes from the evaluation program, any guidance should be correct. Okay, the moment you give an incorrect guidance, it's like game over for your evolution algorithm because you are going to generate the wrong ones. Okay, so this is very, very important. And this kind of gives me some insights like, maybe you want to restart the guidance once in a while. Like let's say you have a list of past solutions, maybe you want to start from scratch again. Because past solutions can contaminate your generation. All right, you may not realize it because you might think that, hey, more solutions better, right? Wrong. Okay, if let's say your solutions all start with LO, like the John's case, it start with LO, and you might get stuck thinking that, hey, the answer starts with LO, which is what happened in the AlphaEvolve that I created. Yeah, so if you just restart again, you start with only one solution like LOIN loin, right? Maybe it might able to evolve to John because it doesn't get contaminated by past solutions. So quite interesting insights here, right? There's various ways to evolve, and a lot of them. I think if you take away one key thing from the AlphaEvolve paper and from today's session, is that we need to give the right guidance. And number one, give the right guidance. And number two, make the context clean. All right. We don't want to, contaminate it with wrong solutions. Yeah. So it's quite a dance between like how much to give and how much to evolve. And maybe a third one, small improvements can accumulate because an LM itself cannot generate the whole solution, but if you evolve it in multiple steps, you might get the right answer. And I was quite impressed. It managed to get the word John from the medium hint, which is like start with J. And if the solution did not, if the whole architecture did not learn from the past mistakes it made or past evaluation it made, it would never have gotten it. The fact that it managed to guess the name right shows that it can learn, and that's interesting. Okay, so I think I spent a lot of time talking about the code and everything. Yeah, but I hope this was useful for everyone. So this is the step through the process. I'm just going to skip through this a bit. So you basically give evolve block start, evolve block end, and then they will evolve this part of the code. So you don't have to evolve the entire pipeline. Okay, you can evolve section of the code. All right. Just now when I showed you the AlphaEvolve code that I've created, I just evolved the whole block because my code was short. But if your code is very long, the whole database and so on, just putting this text here can tell the LM, hey, focus only on these blocks. The rest of the blocks keep it the same. Yeah. So that the LM, can focus its search space. So this is very important. This constrains the LM solution space because sometimes if you have some pre-processing block, let's say you're doing some like MNIST digit classification, you want to use the image pipeline that is fixed. You don't want to change it. So maybe you only change the convnet like over here. Yeah. So this is quite important, and I think this is what they did correctly. Next, use the prompt to generate the new code. So we give you all the past programs, all right, that are good. Give you the current program that is something that you want to evolve from. All right. So you give it some context. So I've done this in the AlphaEvolve that I've created as well. And then after that, this is the current code, right? So your task here is to create a new idea to improve the code, okay? And describe each change with a search replace block. So this is the code evolution. Next, we use the LM to generate the changes to the code. So it just, over here, this is the reasoning process. So similar to what I did with the analysis and thoughts, here you reason, okay, we can improve the performance by adding model capacity and adding regularization. Search for this block, and then replace with this block. And then search for this block and replace with this block. So you can see this actually is a chain of thought prompting to edit the code based on the idea. And this actually works quite well because chain of thought works well for LMs. They can use the past, like whatever they output as thoughts here will be used as the context to ground the generation. So it generates better solutions in that case. And the fact that you only ask it to replace selected blocks constrains the search space a lot. And this helps to, let you evolve the code properly. And one more thing, LMs are actually quite good at iterative correction. Like if you have a code that has an error, you copy paste the code there with the error message. The LM is quite capable of correcting itself. And this, in some sense, is a corrective mechanism to correct itself to, achieve a better score. Okay, but of course your guidance must be right, all right? If not, you correct wrongly, right? So this is the generic changes to code. Next, we evaluate. We provide the test cases to test out the solution. And based on the test cases, we can also give back the feedback from these test cases back to the prompt as guidance. So everything is guidance, you see. So we don't have to start from the hardest test case. We can start with increasing difficulty. We can do like level training. Like level 1 is the easier test case, level 2 is harder. So once they solve level 1 effectively, we can, move to level 2 and so on. So at each step, so this is very important, okay? Don't do something that is too drastic. Okay, you always do cases that have room for learning. So make sure that LM can learn effectively, right? You don't want it to learn on something that is too hard for it to learn right now. So it needs to evolve slowly in stages until you reach the final goal. So, if your test set can cater for that, this guided evolution is awesome because you can get guided at every step of the way until you reach the goal, right? So next, you can also use guidance that is based on some user-defined criterion. Then you can ask the LM to output, predict, or reflection, and then you can use this reflection to evolve as well. So this is very similar to the reflect loop. Okay, after you do your output, you reflect and then pass the reflection back to generate the next action and so on. So yeah, I mean the paper that you can read on for this is reflection. Yeah, so you use the reflection to ground the next action. Okay, so you can also put this in the AlphaEvolve loop. You can also do parallel evaluation, okay, so that you can try out on different initialization input sets so that, when you generate one structure, so this is actually more like if you have a meta structure to evolve, then you can do stuff like, Bayesian optimization. You can do stuff like, I don't know, random permutations to try out all possibilities within a certain bound, or try out promising possibility, because you can't try out all, right? I mean, there's too much things. So it's very possible to evolve in a meta structure, like give the convnet with 2 layers, but how you want to initialize the weights and biases. Maybe you can use some other algorithm to evolve it. So it's a 2-step evolution process. The top step done by the LM, the bottom step done by a bit more structured algorithms. All this perfectly fine. Okay, next. Step 5, evolution. So yes, sorry, yes, go ahead.
One thing from one point you made a remark previously on the GRPO. I don't get how is that related to that particular statement.
GRPO evolves by using objective ground truth. Like they do it on coding exercises, they do it on math problems.
What do
So
you mean
that
by evolve in this context?
say again?
What do you mean by evolve in this context?
You mean GRPO?
Yes.
GRPO evolves in the sense that you select right trajectories. So I just draw GRPO here, okay? So GRPO is like that. You sample multiple times from the same model. You get different trajectories. Okay? These are your trajectories. You sample n trajectories. Choose like then you score them based on the relative score of each of all traces of all trajectories, and you just improve the policy based on how good it is. So in some sense, this is a way to make sure that everything that you learn from the better ones. Yeah, of course you can also do an alternative form is you select top K and put them in training set. So in some sense, GRPO, the DeepSeek algorithm also did this. They train back from DeepSeek V3 and then go back to DeepSeek R1 by sampling from the trained model some good trajectories and put them back. So
I don't
that,
think these two are mutually exclusive, right?
say again?
I don't think these two, you call it alternative, but I don't think they are mutually exclusive. In fact, for DeepSeek, they have to use both.
Yeah, correct. So
And so actually, so I think just to clarify, my understanding, so my question is on what we mean by evolve in this context. So now my understanding is based on your explanation. It's basically a way to optimize your policy, right?
I mean, in this case, there's a policy because GRPO has a policy network. But in AlphaEvolve, there's no policy network.
Yeah, that's why I can't find the connection, or I don't know what exact thing you're talking about.
I'm saying that GRPO uses objective scores to improve. So these relative scores are all based on objective scores. If you don't use objective scores, you might end up improving wrongly, because like how good this trajectory is, if we ask an LLM to say how good it is, you might end up in a loop, because sometimes LLM say it's good, sometimes LLM say it's bad for the same piece of
I see.
code. Yeah.
But I mean, this is a different level, right? Because GRPO is used to post-train the LLM itself, but in AlphaEvolve, we're talking about the whole system, which has LLM as part of its components, right? So it's really like different level.
Yes, correct.
And indirectly, if you are using DeepSeek as your LLM, the LLM plug-in component, then you also can use the GRPO can be like in a way like it's part of the method used to evolve your system as well.
Oh, definitely, yeah. So when I say GRPO is similar mechanism, actually what I meant is the objective evaluation function. Because without this objective evaluation function, the evolution might be guided wrongly.
But even in AlphaEvolve, they still need the verifiable like I mean the whatever you want to solve, you still need to have an automated way to do evaluation,
Yeah,
right?
correct. So that's similar to AlphaEvolve. They have automated
I see. Okay, I
yeah.
see your point. Okay, yeah. Thanks.
Yeah. So this is important because a lot of papers talk about LLMs as a judge, LLMs as a critic. Honestly, LLMs cannot judge and critic themselves quite well because you might always think like a bad example is good if it doesn't have the prior knowledge of it, and then you can get stuck in the loop. So that's why you see let me go back to the slide earlier. One of the thing is grounded using code execution and automatic evaluation is very important, because if you use LMs as a judge or critic, as I say, you might get stuck in the loop. You may not learn correctly.
Sorry, can I just a little bit add on here? So can you give the one specific example where you are saying LM as a judge is actually is a bad idea? Can you just give one concrete example?
Oh, yeah, definitely. So let's say you have a student essay, right? And the essay is like talking about, maybe talking about topic A. And in the ground truth for the LM, maybe LM thinks topic A is good. But in terms of the essay itself, actually, ground truth is, or rather the maybe a preference for humans is that topic B is good. So you may not evolve to topic B because the LM always thinks topic A is good, give it a good high score, and then the evolution process will get stuck at topic A.
I see. So here you need a human in the loop, right? In order for it to
Correct. So
okay.
if you want to do like preference like this might need to be in the context.
Okay, yeah, sure. Okay,
Yeah.
I get your point. Okay.
Yeah, so if you have an automated evaluation here with objective ground truth, then maybe this guidance is not needed because your objective ground truth here can give you the guidance.
Okay.
Yeah, so as I said, this whole paper on AlphaEvolve, the key takeaway, if you ever have one, is that guidance is important. Right? I mean, I simplified the entire AlphaEvolve paper, and my experiments also have shown me that. So the
Wait, if you already have the automated evaluation, why do you need a human guidance?
sometimes you take very long to learn from your automated evolution, especially if your search space is large. Like, find a four-letter word. There's many different four-letter words, right? If I don't tell it,
Yes.
the four-letter word
Like a
starts with
shortcut
J.
from the human bias to give you a shortcut.
That's right. So if you already have something that you know is correct, why waste time on the rest, right?
Okay.
Yeah. So any guidance, especially those that are confirmed to be correct, are good ones.
Okay.
Yeah. Of course, this kind of reminds me of something. Like sometimes maybe having too much guidance is not good. Okay, so we have to do some research on that, because sometimes people might think that the correct solution is using this few steps. But history has shown that a lot of math problems, people always think, hey, I should solve it in this certain way because that's how other math problems are solved. Sometimes constraining yourself in that thinking might lead to worse results, because you might need to solve it in a different way, like maybe using pictures, using knot theory, like something quite different from the traditional way of solving. But because of our human mindset, we think that we should solve it in this direction. So there's some caution here, as much as guidance is good. Sometimes guidance might constrain the creative thinking of the solutions. So it's as I say, it's a dance of how much context to provide. Yeah, how much guidance to provide. Okay. So now is talking about last step evolution. We continually generate a growing number of solutions with evaluation results. Okay, scores and program outputs. Just now in my AlphaEvolve version, I did not do the program output because the program itself already has the output. Okay, but you know, if you have a very complex program, you might want to give the program output so that the LM will know whether or not it has generated the right program. This is more like to tell the program, you know, whether your code is correct, right? So these solutions are stored in an evolutionary database, and you know, you can optimally resurface previously explored ideas in future generations. And it's important to sample properly because this will guide the LM code generation. So of course, this is a whole new topic to explore what kind of sampling to use. Over the paper, they use this thing called map elites. If you're interested, you can see like this is selecting in a low dimensional search space, like to map to higher level ones. And then there's an island evolution where you evolve multiple islands together, and then you select the best one from each island. There's many variations of this. People have done genetic algorithms for decades. So you just mix and match some good ideas in genetic algorithms. You might be able to select some good ones from there. So they say AlphaEvolve, they use a combination of both. No specifics given as to how they do it, but it's not very important to me because this part of selection is really just about, you know, you need to see the problem and then you select accordingly. Yeah, there's no one size fit all for this. Okay, some additional details in the paper. So I like this a lot, all right? I like this a lot. So different levels of abstraction space to evolve. So you can not only evolve based on your problem, you can evolve at different levels. You can evolve at string representation, like you want to evolve a gene, like basically a gene in evolutionary algorithms means like a list of parameters. You can evolve that, right? So you can actually do genetic algorithm with this AlphaEvolve. um, you can also evolve a function of a definite form. You can evolve a search algorithm to find the solution, all right? So basically this like the, you know, this search algorithm can be used to select good samples, or, you know, this problem might be a search function itself to find across a wide range of possibilities. So that could be the answer. And you can even evolve your algorithms and the search together. So many different ways to evolve this. I think this is something that is quite cool because there's no real one level of abstraction that is correct. I mean, let me give you an analogy. For example, if you have this, like you want to evolve words to form sentences, right? One way to do it is to evolve letters. But you know, it takes forever and it's not even in the right semantic space. But you can evolve words, then maybe evolve to form sentences. Yeah. Evolve words is a better semantic meaning. So if you evolve at the level of letters, it may not be a good idea. But if you evolve at letter of words, it can evolve in a more coherent way. And you know, that's why LLMs uses subwords as tokens rather than letters, because of the semantic meaning space. And this abstraction space is really important because how well you solve a problem depends on how easy the problem can be mapped into an abstraction space or into multiple abstraction spaces. So AlphaEvolve just gives a framework to self-improve based on certain code blocks to modify, but you can always improve on the base algorithm to, you know, modify different kinds of code blocks at different levels. Yeah, quite a lot of possibilities. So as I said before, it really depends on the problem. So maybe one day we can have a meta evolution algorithm to tell you what evolution algorithm to use for the problem. Yeah, but that's another topic for another day. So quite interesting things here. Prompt sampling, very important. So comprises multiple previously discovered solutions sampled from program databases, system instructions as to how to propose changes to a particular solution. So it's like my hints, all right? We can also give it explicit context, can give it PDF files, can give it human written instructions and so on. So all these are guidance. Stochastic formatting, stochastically generating based on human-based solutions, like maybe the best known solutions, you try to expand that search space here. And over here, they use probability distributions to, you know, try to sample different parts. Because this is something that LMs are weak at. LMs don't sample very well. So you might want to use probability-based sampling for that. Next, we might even give it rendered evaluation results, all right? So, you can even give it images, if it helps to let it understand what it is outputting, especially with multimodal models, it can understand the images, right? Next, we also have a meta prompt evolution that the LM can guide itself. But I want to caveat here, this is extremely unstable, right? I've tried it and it got me worse results. So maybe if you want to do meta prompting, you need to meta prompt in different islands. Okay, you don't want to contaminate your meta prompt from one island to another so that you still explore more search spaces. Like the moment you get stuck in your own meta prompt, you might eliminate most of your search space already. And if you eliminate the wrong search space, you will never get the answer. Okay, so quite a big insight here. Meta prompt, while people think that giving more guidance is good, if your guidance is not grounded in anything but previously inferred patterns, you might infer the pattern wrongly and you might guide it wrongly. So food for thought. All right, so ablation, of course, they have to show that everything is good. And actually, I quite agree because in my experiment that I did with AlphaEvolve stuff, if you do everything correctly, you will get best. Over here, they did not. They took away the meta prompt evaluation, and I think if you actually use the wrong meta prompt, you might actually get worse than this. So obviously, they have already used quite good meta prompts somewhere. Yep. So if you look at everything else, it's quite expected that if you have no context, no full file evolution, and so on, you get worse performance. Small base LM, same thing. So yep, basically AlphaEvolve, the components have already been well selected to evolve the code. And it's quite interesting why they use code, because LMs do code very well. So it's playing to the strengths of the LM. So you can see all this. In fact, humans have evolved to use the LMs in this way because this is what LMs are good at. So as I say, it's a matter of how you utilize LMs for what they're strong at and complement the LM's weak points with other structures. And that's what AlphaEvolve is. Okay, I talked quite a lot. Let's talk through. Yeah, I know it's a little late, but maybe we can spend 5 to 10 minutes talking about this questions to ponder. Before I start on the questions to ponder, because I've covered quite a lot of slides before that, I just open up to everyone here if you want to clarify or ask anything I've just covered. Now's the time. Okay, if not, let's go through the questions to ponder. So the first thing that a lot of people ask me is that can this be used to do research, right? Because AI research is quite a big thing. In the recent ICRR conference, the AI scientist Sakana AI managed to publish one paper in a workshop. So yep, are we able to self-evolve in the sense that the papers get better and better, and eventually you can just do automated research, right? You don't need scientists anymore, right? Can you do that? My answer right now, I think, is cannot. Okay, because because there's a limit to how much guidance can work. Okay, there's limit to how much you can guide the paper uh generation, and also peer review is highly subjective. So if you are talking about evolve the paper to make it objective, where like experiments can be verified and so on, I think it can. But if you want to evolve it to pass the peer review system, I think cannot, because humans are filled with biases and just like LMs. So it depends on what reviewers you get. You get the right reviewers, your paper goes through. You get the wrong reviews, your paper doesn't go through. So if you're talking about passing the review system, I think it's like a coin toss. But if you're talking about creating papers that have verifiable results, repeatable experiments, yes, I think AlphaEvolve can do that, because you can have your evaluation function as read the paper, code out the experiment, and replicate the results. So depending on how many results you can replicate, that is your evaluation function. So it can actually help to do repeatability. It can also help with language, because LMs are good with language. So with this kind of feedback functions to the paper, maybe it can work. And yeah, I do think AI scientists right now, they also have some feedback loop that does something similar. So I think AlphaEvolve might be able to evolve papers. Um, whether it can evolve good ideas, like can we get the right initial ideas to experiment? I think it's maybe, because like, as I said, everything is all based on human interestingness, right? Like the AI might think that this is promising, but to us it's very boring. Yeah, so it's really about fitting our expectations. And that's why if you have a human in the loop, human guidance can help search the interesting search spaces. So I mean, that's my take on academic papers. Anyone else want to talk about it? Okay, if not, the ArcAGI challenge is like, you IQ test for the LLMs, you have an input grid and you try to get the output grid. I think this actually has a very nice objective function because you can tell the number of squares that are correct in training examples, or basically you give it the eval examples or training examples, you can tell how many squares are correct. Even you can tell which squares are correct. So this is a very natural objective function. You can use this to evolve the program. And even before AlphaEvolve came out, I have done some iterative reflection loop and it works quite well. So I'm quite sure AlphaEvolve can solve the ArcAGI challenge better. All right. So yeah, the next question is, what if there's nothing objective to evaluate, like essay writing, music creation, like it's all very subjective? Can AlphaEvolve work? Okay, so I'm not going to give the answer for this. I'm interested to hear your thoughts. Do you think we can evolve to suit human preferences if we have no objective automatic function available for us? Anyone?
I think you probably either need more intensive involvement of human in the loop, right? That's one way to go. Another is you probably need a something like meta reward model, right? I mean,
Okay.
Oh yeah, go ahead, finish.
at the end of the day, so I know like this line of work are all like hinges on the idea of verifiable reward, right? But I mean, at the end of the day, the way I think about it is, verifiable reward is just another way to very quickly give you a feedback signal, and if you can have a good enough reward model, it's the same thing, right? Yeah, but of course there are caveats such as, for verifiable reward you can be assured that if it's correct, it's correct. If it's wrong, it's wrong. But if you are involving things like a subjective evaluation, like preference, human preference, things like that, then, well, I'm not. It's not clear to me. If you because a lot of, for example, I throw back to the DeepSeek R1 paper discussion. The fact I'm thinking of, I think the fact is that you can see the emergence reasoning behavior, right, even during training, is might hinges on the fact that your reward is guaranteed to be correct, your reward signal. So I'm not sure if you substitute that with a subjective signal, if you can still have that kind of immersion behavior. That's something not clear to me.
Yeah, I also don't think it's possible. Like, I think if you just based on reward, so this is my gripe for my 5 years of PhD. I feel like if you just based on reward alone, it may not be enough to learn, because like you may miss out the nuances of why that reward is given. Like, why is it high? Why is it low? What can you learn from it? That may not be very reflective. Like, if you want to punish your child for doing something bad, reward your child for doing something good, but you don't tell your child why he's being punished or why he's being rewarded, but just give maybe a score, like like how many candies, or how much clothing. That kind of thing makes it very hard to learn. And if even this is not objective, then it's even harder to learn because your this reward can be wrong.
I
Right?
I agree to some extent, but my counter argument is, how are you going to incorporate you are basically this is basically a credit assignment problem, right? If you are too your supervision is too low level, like you are micromanaging the training, then you know there are already paper talking about it, like you have reward hacking problem become even worse, right? Things like that. And your low level supervision might not be as effective. You might constraining too much on the creativity side of reasoning, things like that. So it's like a trade-off, I feel.
Mm,
And more importantly, I think from what we can observe, like if you use the best reasoning model nowadays, right? Even though they are trained without like the low level supervision, but I feel like from what I observe, the reasoning traits are pretty good, to be honest. So somehow it learns to have sound intermediate level reasoning. So that's I mean it's not guaranteed, but it's a good sign. Yeah.
yeah, interesting. In fact, I think one way of getting this done, based on what you've talked about, is like after each generation, we get humans to give feedback about whether or not it's good or not. I mean, that can be the guidance, right? Then instead of an automated feedback, we have human feedback. Say, hey, the essay is not very good. It doesn't cover these topics. Or like, oh, this music a bit jerky at the beginning, not too smooth. That kind of
During
stuff.
deployment or during training?
During deployment.
I see.
Yeah, so it's something like you're actually doing this every time you talk to ChatGPT. When ChatGPT gives you back a response, you say, hey, this function is not very good. I need better optimization at the front part. Or like, hey, your pre-processing is wrong. Or like you give it the error message for your code. Or if you ask it to generate like a sales pitch, you might say, this sales pitch is too long. Maybe make it a bit shorter. Or maybe talk about the current trends more. When you talk to the LM, you're actually giving your own reward. You're giving your own feedback, human feedback to the model, and the model can generate based on that. And so it is very likely, if your AlphaEvolve loop involves very subjective evaluation, then just get the person who's going to use the product to evaluate. Yeah, I mean, you can evolve based on that subjective evaluation.
Sorry, but how is it different from how is this being used currently? They are also given, I mean, for the human in the loop factor, they are also doing the same thing, right? Essentially, it's the same thing.
Correct. So in fact, for AlphaEvolve, the human in the loop might happen at all stages, and it might even influence the starting solution, influence the heuristics use, it might influence the evaluation functions use. So yes, in this case, AlphaEvolve does take into account human feedback, and I do think this is the way ahead, because if we want to create systems to target humans, humans need to be the judge, not the LM. And in this case, AlphaEvolve does have a framework inside for human evaluations to be there, human guidance to be there. Yeah. So, I mean, quite promising. You can see that AI human hybrids have created very promising solutions. And that's because humans can guide the search space and the LMs can, evolve based on its prior knowledge. So I think this is quite promising. And I do foresee that, if the model is good enough, it may be able to incorporate this subjective feedback and improve itself. Yeah. So one last point here, I want to say, this is no longer reward anymore. This is actually a goal or intent-based feedback. Yeah. So we actually don't really like reward-based models because rewards tell you very little about why that reward is high or low. But if you give an intent-based feedback like, hey, the music should be a bit smoother or should be a bit more rock-like, that is goal-directed learning. And the LMs do goal-directed learning very well. In fact, for the John case, like if you just say that if a goal-directed learning, you can just say like 3 letters are correct. Maybe you use join. Maybe the feedback could be like 3 letters are correct. One of them needs to be changed. I mean, this is basically the same feedback as saying 3 positions are correct, right? So if you can give some form of goal, like saying, in fact, the goal could be like change I, then that would make the LM evolve much easily compared to the reward model. So if we can convert that reward into some goal or intent, I would say that AlphaEvolve would be improved massively. Yeah, my entire PhD was about doing goal-directed memory-based learning. So I think, using reward as an evaluator only works for certain problems, but for most cases, if you have your intents, it works much better. Yeah, I mean, you can tell that when you talk to ChatGPT, you have a specific intent, they try to evolve the response to fit yours. Yeah, so that is quite telltale of, this is the better way ahead. You try talking to ChatGPT and you say that, oh, your response is a score of 5. Your response is a score of 1. Your response score of 7. You see how long it takes for the GPT to give you the right phrase or word you're looking for. Okay, I can tell you it takes forever, all right? So, but if you can tell you a specific intent to guide towards, let's say you want it to output the word John, you can just say, hey, output the name starting with J. It helps you to ground the LM much better with that intent or that goal. And yeah, I think that is probably the way ahead for evolution algorithms. You need an intent and goal, and AlphaEvolve does it in the form of human guidance. Human guidance provides the intent and goal. Of course, if you have human in the loop at every step, it will help to speed up the process much faster. Okay, enough about me. Anything else you want to talk about for this?
Just to give my comment on the first question, just now I missed it. So I think it's definitely possible to use this kind of framework for those kind of tasks. In fact, this is as what Jason Wei has commented on his X or Twitter, right? This is like a orthogonal way to scale compared to like you scale up RL. This is another orthogonal way. And in the paper there, I think they also mentioned that with a better LLM backbone LLM, they have better performance, right? So these two are like very synergistic. One is on the system level, one is on the model level. So basically, this gives you a confirmation that you can scale yet on another axis. So yeah, now we have even one more axis to scale.
Yeah,
Yeah,
very cool.
I wouldn't say it's like entirely new insight, but I think maybe the fact it works so well is because their base model is just very good, and there may be certain design in their architecture that just made it work. Yeah. But I mean, the same idea can be seen from previous work as well. For example, Voyager. Essentially the high level idea is the same, right? You as what you shared. It's not a scalar feedback. It's from the environment you observe things, then the model are given more nuanced feedback, richer signal, so it knows what to learn next. So this idea is not new. I agree. But yeah, I think maybe something in their system design is just very, very good. Maybe it's the evolutionary part, which is maybe not seen in this line of work before.
Maybe it's the human guidance.
Maybe actually, I'm not sure. Do they have a
They have they're working
domain
with Terence
expert?
Tao.
Do they have a domain expert?
They're working with Terence Tao, the one of the Nobel what Fields Prize medalists for math, and they're working quite closely with him to do AlphaEvolve for math.
Really, is he involved in giving the human feedback for the discovering the matrix multiplication?
I'm not sure how involved he is, but he's definitely involved in AlphaEvolve.
From the interview I've seen, the message I got is like it's just their usual stuff. Like no, I mean the scientists, they're DeepMind scientists. They are not necessarily experts in mathematics. They are just working on AI. Then somehow they are. I mean, the interview what they said is, "Oh, we are just trying to run more examples to create a complete table for our paper, right?" Then somehow they just very incidentally discover this result. Yeah. So the message I got is like you do not need domain expertise to get it.
Definitely. I mean, the LM itself can be a domain expert already.
Yeah. So that's going back to the point. You need a very good base model to do it. Yeah.
In fact, I use the LM as a domain expert for my coding as well. Sometimes I don't know how to do async processes and so on. The LM codes it much better than me.
I mean, of course, if you're talking about coding, basically all frontier models are domain expert in coding. I would say.
Mm.
Yeah, anyway, so that's my comment on the first question. Like, yeah, it's definitely another skill, another axis you can skill for more challenging tasks, like AI scientists or the R challenge. I think both are within the scope of what this system can do.
Definitely. Okay, anyone else before I move on to the last question?
This is James here. I think this question about when there's no objective evaluation, right? Or the evaluation by itself, right? Number one, just my first instinct is that, like you had mentioned earlier, there should be eventually AlphaEvolve will evolve to define the objective function, right? At some point at the meta level. That's one, right? Second, second is that it doesn't need to be linear, basically. Right now, it's kind of like you must continue go in a certain direction, right? And there could be things that you do like a truth maintenance system where you actually make some assumptions. Then you go involve, then you continue with your current objective functions. Then you may come back and say that, hey, is that the objective I want? Huh? Does it know how to go and revise itself at the meta level as well? And I think because no matter how you try to come up with objective functions, if you're solving a game, no problem, right? Because it's clear. Creativity, there's no right and wrong. Maybe you do a music because you want to shoot a movie for a Hollywood movie. That also become very fuzzy, right? As we saw human, we actually learn what we want. Because objective function is why you are doing something, right? The purpose is always evolving itself, let alone the learning itself to fulfill the objective. Again, that's part of it, right? So I think there are actually many elements can work on. I think the gentleman in the chat group has mentioned, right? This is just the beginning, and we need to ask a lot of questions on that. And I think if you go back to the computer science or AI literature, right, the truth maintenance system is a way where we humans have performed adaptive learning, right? You assume certain things, then you move forward because there's no way you know everything. But we human has common sense reasoning, right? So this feedback that you provide to the object is actually human common sense reasoning, where even John, you provide the feeling you don't represent the world, but you represent a point of view because you have some common sense reasoning that more or less we assume that you have the altruistic objective. Like you're not there because of political reason, right? Yeah. So these are very interesting social and architecture issue that we can discuss. And my actually very interesting thing is that which I meant to idea earlier, right? If DeepMind can want to build AlphaEvolve, why don't we have people in Singapore doing the same? Because I think the idea is not that breakthrough, right? It's just a matter, do you have the engineering, the resources to go about putting the researcher in Singapore to do it? But why are we constraining ourselves that we have to follow? Because I think it's not difficult to imagine to use, instead of reinforcement learning based on a certain method, you're using large language model. Actually, it's not that big a breakthrough. It's just that we need to have the people who are willing to go and try it, basically, right? Yeah. So
I mean, it's not
that's
difficult to implement AlphaEvolve. I've implemented it in a few days.
exactly. It's not difficult. It's coming with the idea, right? Actually, you talk about AI scientists. Actually, doing AI scientists, the difficulty is not to evolve it, it's come up with the question itself, right? What do I want to solve what problem, right? Basically. And I think that is this area of evolution of AI, which I'm speaking to different people over the world, right? And I think it's a very worthy questions to ask within the Singapore community with all the expert like Derek and Ziyu and Matt, right? And yourself. And I feel that there should be more conversation on that. And yeah, that's what I like to say because this one is a lot of abstract issue. It's very philosophical. It's no longer just an engineering problem. Yeah.
Yeah, I mean, definitely. This one, community-based implementations are definitely encouraged.
Mm.
Yeah, but I mean, just to address some of the things that you mentioned just now, like you said, you might be able to evolve an objective function for a non-objective problems. Actually, that one I don't really agree
Mm-hmm.
because subjective things very hard to write into a structured code, right? Like if you like the music, very hard to say, oh, I only like rock, I don't like country music, I like only fast beats. But sometimes your taste and preference change based on the day and stuff. So
Sure.
I mean, you can say yes, you have a meta level objective thing, but the fact is, if you want to evolve, you need something stable. So it means that very likely for this kind of domains, you need the human in the loop at all steps. Then you can
Mm,
evolve more meaningfully. Yeah.
mm.
So yeah, that's
Agree, yes.
but if let's say you're talking about stuff like maybe Arc AGI, then yes, this one maybe yes. You can use these objective functions to basically evolve in a limited domain or limited search space. Because you say that this is important, like you want to maximize the number of colors, that kind of thing, you can evolve in that limited search space. If that problem is related to it, I think you can find a solution better. There's this quote by Claude Shannon, one of the information theorists. He said that like to solve problems, like, I might misquote him, but this is in gist of what he means. You need to know many different other solutions. Then you can form a a search space that is most promising.
Yes, agree.
Yeah. So this idea corresponds quite well with what you mean by, create a new objective function that, can potentially solve problems
Yeah,
better.
maybe interesting discussion, right? Let's say if you are in the fixing a certain problem, then you can define that more objectively with a certain goal, right? Let's say a company want to achieve maximum revenue profit, right? But if you're in the creative space, right, you don't necessarily have a clear objective, right? And then of course you also in the creative space you may have to serve a certain business function of some output, right? Because you are shooting a movie with a creative idea, Mission Impossible #8, right? For example, right? So then you also have to have some grounding now in terms of the scope of the search space itself, right? Yeah, I think the discussion about objective function itself is actually very interesting. There's so many variation, not just the evolution mechanism of reasoning to achieve the objective functions. Basically.
Yeah, definitely.
Mm.
Okay, so in the interest of time, let's go on to the last question because it's quite late already.
Mm-hmm.
So the last question is whether or not, because we are using code as our output space right now for our candidate solutions, is code enough to model every single action or like every single solution to the problem? And I would like to say that, most cases, yes, because like text can be represented as code. Like for example, in the case of John, you can output the text. Even like algorithms can be represented as code. Even meta structures can be as code. So actually code can give you quite a lot of things. But one thing that code cannot really do, okay, maybe it can, but cannot do it natively. Cannot really do like actions in a simulator with like various other actions. Maybe you can by putting the simulator in your evaluation function. But what I'm talking about here is like, a robot interacting in the real world. Like your evaluation function will depend on like the people around you. And okay, maybe in this case, you can still represent the algorithm as a code because like how the robot moves is actually code. It's more like this one is more like the evaluation function itself may not be objective. So if you want to do this in an embodied AI, AlphaEvolve kind of thing may not really work. So I to answer my question on the is code enough, I think yes, code is enough, but code based evaluation may not be objective because it depends on the environment. So in the cases like math is always objective because the environment doesn't really change. But in the real world, things change, and like the same action, like for example, go from point A to point B. Um, Initially you might go upwards. Okay, let me just draw your map. Okay, initially you might want to draw upwards like that from point A to point B. Initially you might say, yes, I'm just going up to reach there. But what if one day, even before you do this planning, you already have a wall here that, some construction work, you need to route it across. And if you just do this here, you might, based on your evaluation, get a very low eval, saying that, hey, this is not good. But, it may only be present for one day, and then maybe you get stuck with this evaluation and you go somewhere here, and then you get stuck with this forever. Yep. So you need to kind of know, if the evaluation function can change, how do you try out? How do you explore back again? And I think RL explored this quite a lot. Explore, exploit. Sometimes you explore previously bad solutions. But in the case of AlphaEvolve, because all your solutions are in a solution bank, and your solution bank is used to ground new generation, maybe the only way to get you to explore back again if the environment changes is to start anew from scratch. Yeah, so I mean, I think there are mechanisms in AlphaEvolve that can help you to explore again. It's just not the usual form. You need to purposely, explore again. But yeah, I think code itself can model the action spaces. It's just that the evaluation function, we might need to use different structures in order to do more exploration if the evaluation function can change. That change without influence on your part. Like, you can do the same action based on the same context, but just because what other people are responding to the situation, you might get a different outcome. Yeah, and that's the nature of the real world. I think this will make it hard to evolve a lot of things because what you think is right may only be right for that particular context. Yeah.
Yeah.
Okay. Any comments? Things discussion here for this? This is a hard problem, by the way. Yeah.
I want to still like I always want to mention this example. So I believe you have seen the demo from Unitree, right?
Yeah.
Yeah. So I believe they are using the same approach as NVIDIA, how they approach this embodied AI problem. Simply is just to brute force the simulation. And simulation by definition is constructed by code, right? So that means you can just use code. Code is enough to construct simulation. And if you brute force your simulation, even though you have so many possibilities and stochasticity in real world, like somehow it made it work because we have seen a demo. And but I on the whether it works with this framework, I think I'm more pessimistic because a human in the loop problem. If you have human in the loop, it's very hard to scale up in deployment. I mean, in training, maybe if you don't have the human, you can brute force it. But how are you going to brute force it if you have once have the human in the loop? So, but maybe they can during the training time they can just front load all this brute force during the training, and during deployment maybe they already have enough um, accumulated enough experiences, then maybe at a time you can add in the human. So I'm not very sure, but back to this problem, I think I agree. Like you are using the embodied AI as example, which I think you can use code is sufficient. But I mean, maybe there are other cases where code is not sufficient because code is a very formal way to describe things, right? But you can have very abstract idea and you have very abstract learning problem. Like I think you also mentioned before, if you want to have an efficient way of defining policy, then you might need a very abstract latent space to define your actions. Then um, how are you going to do that with code? Because it's even hard, it's already hard to describe that abstract space in a
Unless you already code out the structure for your latent space.
But
Yeah.
how? Like especially when it's so abstract, how are you going to do it? Sometimes the thing with ML is it can help you, they can learn it, even though you cannot formally describe it, but you can learn it and approximate from the data, right? So if that's the case, for that kind of cases, I think it's hard for code.
What if you do code to define the abstraction space using
As I said,
embedding space? Yeah.
I think it's gonna be hard because it's too abstract.
I mean, technically, we code out our abstraction spaces as well by using embedding spaces. You can technically evolve that embedding space. You can because it's still code, right?
But you are saying it's code enough to model the.
Yeah, I mean, it just which level of code. You might evolve the code used to generate your code.
Okay, I see.
Yeah, yeah. So it never ends, you see. In fact, real world is like that. There's multiple layers from the subatomic level, atomic level, physical level. Maybe people talk about consciousness level beyond the physical. There's different levels of ways of processing data.
Yeah, my point is I'm not very sure if code as a form of formal language is it enough to fully characterize everything you need to describe the space for learning. I'm not very sure on that. I'm not expert on that.
That's the question I'm asking now. Is code enough? Because once we can settle code is enough, then the Alpha Evolve framework is great. You can just add on to it. But if it's not enough, we need to think of a new way to do it. Yeah.
Actually, my argument would be code is not, mainly
Okay.
because we're talking about code and language over and over then. And what these systems are complex and powerful means of constraining our abstract world and abstract thoughts into a constrained, structured logic system. Basically, like with language, I am able to talk to you in English because English has certain grammatical systems in place that allows me to confer ideas and trigger thoughts in your mind in a structured, logical manner that's followable and readable. So we can all know what we're all talking about at the same time as we talk to each other through the same words. Um, but the issue with that is that we already have I guess, the abstraction or the abstract
Knowledge base. Yeah.
knowledge base, abstract world model internalized. We already have that in place. So I'm able to talk to you, and you already have those thoughts and ideas triggered in your mind. The issue with language systems and language models is that we've been doing a top-down approach. So we're having the LLMs learn language at the existential level. They only know language. And it's very powerful because language is a structured logic system that can be pattern recognized, just like code. Code is even more logical. It's pure. Um, would you argue? Yeah, I would argue. Yeah, I would argue. I would argue code has a lot more logic to it and a lot more constraint to it. Language is more flux because we humans are able to communicate with a more flexibility. But with computers, you have to talk in a very logical, structured manner to
Sorry, let me
program.
pause you there for a moment.
Go ahead.
What if you can put the dynamic interpretation of language in your code, like put an LLM interpreter inside the code itself? Then you would solve the problem of interpreting language. Like, well, of course, you still need to train the LLM, but that can be done in code as well.
Right, but we were talking about the highest levels of abstraction, right? Not just language, right? Like a language model can do language interpretation, but we were talking about the highest levels of abstraction. And my argument is that language models um are able to pattern recognize patterns in language, but nothing higher or more abstract than that. They only understand language internal reasoning or language chain of thought reasoning, but pure language reasoning or pure language patterns. They don't understand anything beyond that level of abstraction. Now, what higher levels of abstraction look like and what higher levels of abstraction need to be learned by machines to be able to have high levels of intelligence, I really don't know. But I'm definitely sure that language is a really good way to hack into human intelligence for machines. But I still think language is very hacky because language is already codified with certain structure and patterns into it that allow these neural networks to catch on to human patterns and human behaviors and intelligence very quickly, but it's still superficial to a degree. It's still reasoning in language. It's still true language reasoning objectively, but it's still a superficial version of language reasoning compared to human reasoning, because we as humans have all these different other levels of abstraction connected to it. But I still don't know what it looks like. I don't know if there's what do you call it, universal algorithm for abstraction spaces and reasoning spaces where we just apply this general algorithm to everything and we're able to break everything down easily into certain levels of constraints and abstraction spaces. I truly don't know. I think it's a very complicated question, very almost metaphysical question. But I do definitely know that with the direction we're going, it's useful, it's powerful, but I still think that these language models are missing these more basic abilities of abstraction, of innate reasoning, of like base level reasoning, right? Not reasoning at the language level, at the internal chain of thought reasoning level, reasoning at the inherently almost token level, or yeah, I guess I'll call it token level because we humans we have our own version of tokens, but it's not one-on-one to like machine learning. But we have these like basic uh, tokens of computation within our minds that we use to build everything up into. And obviously the neuroscience behind it is a lot more complicated. But it's my point that we need to get these models to reason at the inherent token level on anything, whether it be music, audio, video, um, any even spatio-temporal or even what do you call it? Sensory motor level, right? It should be able to break down anything it comes into contact with at an inherent token reason level. It should be able to tokenize anything it runs into and break it down into a logical system for its own understanding, if that makes sense.
Yeah, actually, I agree with whatever you said. So there's two things one thing I'd like to point out about your argument. I mean, if I would may summarize it, is something like you need to evolve a framework, and then or maybe like a framework of structure, or abstraction space, or maybe extraction spaces, and then you need to evolve based on the structure. So there are two things that can be evolved. One is the structure itself. One is the things you use the structure for. So like in the brain, maybe if you think about it, the structure or this one could be the default mode network where you store your memories in certain forms, and then this one could be your memories or your learn weights. Okay. So this is, I think, something to do with which level of abstraction you want to evolve on. And I think it's not just one layer. I think there's many layers, and it can be quite complicated to model all. But for practical problems, if you can abstract away one whole layer as one heuristic, that's good enough. Because I think to compute everything, you need a very large computer. Because yeah.
So John, this is James here. I think to answer your last question, right, is code good enough to model? It depends to model the possible action spaces of the problem, right? The question is that who is the person receiving the model? There's human and there's machine, right? If a human is taking on it, like I think Derek has mentioned, right, then a right good output to a human to make decision based on your evolution discovery is that you need to give why, how, when, who. Eh? So what? These are the human questions you need to provide for a person to execute on it. And that can be done at the language level, but even be that precise, but at least it provides the solution to the human to make decision, just like you give it to the prime minister or whoever, right? So I think that is one way of solving more higher level abstraction at the economic or social level. But if you are sending to a machine, I think what you have talked about earlier, the architecture, is that we need a multi-layer meta architecture where it's not generating the code how to do it. Just like instead of teaching you how to fish, I teach you, instead of giving you a fish, I should teach you how to fish, right? So the code generated could be generating the code to generate the code that you ultimately will execute upon. Then there might be multiple layer. And one of the ultimate level is like, maybe this is what you should rethink about your objective functions. The machine can say, hey, maybe you need to rethink your objective function because that's might make it very difficult because it's unclear or it's ambiguous or whatever it is, right? So I think these are multiple scenario, but definitely for both cases, you want to have a human in the loop in a sense because you give the human to decide is one outcome, right? You give it the new solution in the code, but you probably want to in the code itself write something into the code to say that at some point ask John for his input, ask the right person for the input in order to as part of the governance, right? And down to the specific level based on the problem. Because if you're solving a code for Singapore context, you need to ask certain people in Singapore, right? Because you do have the world knowledge about who and what and how in that sense. Okay, that's why I thought something that we can extension of what we have discussed. Yes.
Yeah, very nice. Actually, I really enjoyed the discussion today because I feel like this AlphaEvolve really is just touching the surface of what can be done. Indeed, there's a lot more things not coded in there. Derek's point on the abstraction space, I agree. So while everything can be done as code, not everything is easily done in code. Some other processes are evolved with other competing forces. And in fact, just evolution itself based on one objective can be too narrow. You might need multiple objectives. You might need different evolution systems all put into one. And I mean, honestly, we don't know enough of the real world to say that, hey, we learn in certain ways. It could be very well that uh, like the way we view the world, the way we learn could already be biased from the very beginning. Like you want to solve arbitrary problems, I think that can be difficult
Yeah,
because
exactly. It's like the no free lunch theorem, right? You have to give some. I mean, intrinsically, the class of problem you want to solve is already biased. So we should focus on only certain class of problem. And I think Yellow Kun also commented if you provide absolutely no bias, this is just not possible to learn. It's just
Mm.
too many different things to learn. Yeah.
Agreed. So I think bias is important. That's why like guidance is important. So I go back to the concluding statement for just now. Guidance is very important for this whole idea of evolution. And I mean this alpha evolve gives a way to evolve in one particular like abstraction space or objective functions, or you can do multiple objective functions as well. But ultimately the guidance either from automatic evaluations or from the human is very important to evolve it. And in this all this code itself, you might give it external knowledge. And this, could help to solve Derek's thing about like how are we going to put language inside, how are we going to learn the tokens for maybe like sensory motor for language. You could just put different LMs inside. I mean, this is of course a very, very crude example. Because LMs also need to evolve in some way, right? But if you want to model all the evolutions all together in a row, you might run out of compute. So for practical sense, I think it's good to fix some parameters and evolve based on that particular set of parameters. Because with like exploration, right? You can't explore everything. But we just explore whatever is meaningful. I think if you just train LMs on the current world right now, you explore quite meaningful spaces because this is what we view the space to be. All right. I mean, granted, we can't explore everything. In fact, we don't explore everything as well. And I think if you put me in an unfamiliar scenario where the world is not the way it is, like maybe like for example, if you take the world pixels and then you rearrange them in a random way, I don't think I can make meaningful observations of it. But LMs might be able to do it because they can form patterns. But for humans, we have certain biases. I think it's okay to have them. Just put them in the as a ground truth, or put them as a context, or use them as a uh, like fixed function in the code. I mean, I'm talking about alpha evolve sense. But eventually, if we want to understand the true nature of how we learn, we will need to evolve more than this. We will need to evolve in different tiers, and then eventually all this evolution will all come together. So there's one neuroscientist called David Eagleman that mentions like it's competition from bottom to top. This for neuroplasticity. You can read his book called Life Wired. Yeah. So um, I think this is something very similar in evolution as well. Like you evolve in different time scales, and but the thing is, do we really need to model everything from the bottom to the top? I would say for now, I say it's not really needed because it's too complicated, like to model everything. Like if you want to model like the human brain, maybe you don't have to model all the way at the neuron level. Yeah, you might. Oh no, not neuron level, like chemical levels inside the neurons. Maybe you don't have to model that. Yeah. In fact, now I'm also thinking that, maybe the way that we view the brain might also be different because the brain may not contain all the answers as well. Like there are certain ways of us thinking about stuff that is not based on genes or not based on brain structure at all. It's just the way we view things. And uh, it's hard for me to describe right now because I'm still learning more about it. If you're interested, it's more on the topic of consciousness and how it arises. So I'll
So
cover
are you talking about free will?
yeah, correct. I'll cover that another time on how consciousness and how the brain is, because I'm still researching on it. But I do think that a lot of things we think that we learn from environment are actually fixed. Yeah, so we don't really get much of a leeway there. So in some sense, evolution doesn't need everything to be free flowing. You could still have meaningful evolution with fixed stuff. Yeah, so I think AlphaEvolve is quite a nice framework. Any last comments before I end the session?
Yeah, I hope we can continue more discussion on this, especially on this whole new architecture evolution for architecture model for AI. I think good to have a group of people in Singapore discuss. We probably should meet in person. We can organize that.
Yeah, definitely. Yeah. Okay, anyone else before we end?
Do you intend to resume this regularly?
Yeah. Weekly or bi-weekly.
Okay.
Okay, if not, thanks for coming. And yeah, do play around with the code for AlphaEvolve. And we'll see you all again next week. Okay. Next week should be
Good.
talking about action spaces as latent space determinants. So some insights I learned from ICR. So yep.
Yes, please stand up. I'd love to attend to the best I could.
All right.
Wonderful.
And see you all around. Okay, bye everyone.
Bye-bye.